Hi everyone, you're welcome to Explore Insights. In today's video, I want to teach you on how to convert hexadecimal number system to octal number system. More so, I'll be covering when those values are without decimal points and with decimal points. And I believe that this will guide you in understanding this topic. If you're just joining for the first time, do well to subscribe to this channel and don't forget to hit the like button. So without any further ado, let's quickly get started. So in today's task, we want to convert from 16 to octal 8. However, for we to achieve this, there is need to introduce a mediator M before we can get to the final number base. This mediator can either be base 10 or base 2. However, using the binary as the mediator is quite easier. So to better understand this, let me start with an example. So let's start with example 1. I'm going to cover 3 examples in this video, so make sure you watch through to the end of this video. So in example 1, we want to convert 37 in base 16 to octal number system. So all we have to do is to first of all introduce our mediator, and we'll start by calling the hexadecimal value, which is 37. And we'll move over to the mediator. And once we have gotten the value for the mediator, then we convert to octal. So these are majorly the 3 steps we are going to take. Now, first, in this mediator, we are considering binary. For us to get the relationship between hexadecimal and mediator, we know that 16 is what? 2 raised to the power 4. So what does that simply tell us? The highest place value will be 2 raised to the power 3. Then we have 2 raised to the power 2, 2 raised to the power 1, and 2 raised to the power 0. Now, this is 8 plus 4, 2, and 1. Remember, in hexadecimal, we say that the value ranges from 0 to 15. So if we sum this up, this is going to give us 15. However, we are going to use this in this value for our conversion. So this will help us in converting faster. What do I mean? So I'll simply put 8421. 8421 on each digit. So the next thing I'm going to do is to locate the value 3 within here. So what can give us 3 here? It means 2 and 1. So 8 and 4 will be turned off, while 2 and 1 will be turned on. So this is a quick way of converting this value to binary. And then we'll move to the next one, 7. What can make up 7? We have 4, 2, 1. So what does that simply tell us? It means that I'm going to turn the 8 off. Then 4, 2, 1 will be on. Having achieved that, we are going to put that together as 0, 0, 1, 1, 0, 1, 1, 1 in base 2. Remember, this is the mediator value. We are not yet done. We have to convert it to octal. So we'll go further to check the relationship between binary and octal. And we'll say in octal is 2 raised to the power 3. Now in 2 raised to the power 3, that simply means the highest place value will be 2 raised to the power 2. Then we have 2 raised to the power 1 and 2 raised to the power 0. 2 raised to the power 2 will be 4, 2 raised to the power 1 will be 2, and 2 raised to the power 0 will be 1. So what does that tell us? In octal, remember in octal number system, the value ranges from 0 to 7. So add this up, 4 plus 2 plus 1 tells us is 7. We're going to use this for our conversion. So that's the trick we're going to use. But from the mediator to octal, we are supposed to put these 3 values as a set. What do I mean? We are going to take our value from left to right, but consider 3 3 digits as a set. 3 digits as a set. But looking at this, we just have 2 digits. What do? We have to introduce padding. And then that is a set. However, looking at this, we can tell that at the end of the day, we'll get 0. So this is meaningless. So we'll move further to what we have here. Remember, we have to introduce this 4, 2, 1. So we have 4, 2, 1. 4, 2, 1. In case if you're just curious, I will still put the 4, 2, 1 here. But no, nothing appears. So this is just 0. Now, which one will turn on? We have 4 and 2. So 4 plus 2 will be 6. 1 wasn't turned up, so it's just 0. Which one was turned on here? We have 4, 2, and 1. All of them were turned on. So 4 plus 2 plus 1 will give us 7. So what does that simply tell us? It tells us that if we want to convert 37 in hexadecimal number system to octal, we are going to have 67 in octal system. Now, let me consider example 2. Now, let's convert A, B, C, D, H to Y in octal. So we have to find the value of Y. Find Y. Don't forget, sometimes this value can be written as 16, sometimes can be written as H. It also means the same thing. So, which is hexadecimal. So, just like what I said, we have to just use the hexadecimal form, the mediator, which is binary, and then lastly, the octal value. Okay, so let's spread that out. So we have A, B, C, D. Now, let me just convert that to A is 10, B is 11, C is 12, and D is 13. Now, with the relationship I talked about, we are going to use 8, 4, 2, 1. 8, 4, 2, 1. So we'll find which value lies there. 8, 4, 2, 1. 8, 4, 2, 1. So let's see. If we want to get 10, how do we get it? It means 8 plus 2 will give us 10. So I'm going to turn 8 and 2 on, and the rest will be off. So if we are to convert hexadecimal A to binary, this is what we'll get. You can verify that. This is just a shortcut to it. Now let's go to this one. So we have 11. 11 will get with 8 plus 2 plus 1. So that is 4 will be turned off while the rest will be turned on. Now we have 12. 12. The summation of 8, 4 will give us 12. So 2 and 1 will be turned off. Then the next thing we have is 13. 13 summation is 8, 4, and 1. So 8, 4, and 1 will be turned on, while 2 will be turned off. So pretty easy to convert hexadecimal to binary. We have this value. So I'm going to put that together as 0, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, which is in base 2. And then, considering the relationship of binary to octal, it shows that it's 2 raised to power 3. So we are going to take 3 digits as a set. So now I'm moving from right to left. So I'm just taking this as a set. Now in this scenario, I'm left with this 1. So I can't throw that away because it's important. The only thing I need to do is to introduce padding. So 2 zeros as padding. And here we have this. So the next thing I will do is just to put, like I explained here, we have 4, 2, 1, 4, 2, 1. So I'm going to put that as 4, 2, 1, 4, 2, 1, 421, 421, 421, 421. Now, let's sum up. This one we're off, so it means only one was on. We have that as 1. And let's go here. What was on? It was 2. Only 2 was on. Let's go to the other one. What was on? It was 4 and 1. So 4 plus 1 is 5. Let's say in this scenario, we have 1, 1, 1. So we are going to use 4 plus 2 plus 1, which is 7. And in this case, we have 0, 0, 1. So only 1 was on. So we put 1. And this last case, we have 1, 0, 1. So we have 4 and 1, which were on. So 4 plus 1 is 5. So we can tell that A, B, C, D, H is 1, 2, 5, 7, 1, 5 in base 8. So our Y is 1, 2, 5, 7, 1, 5. So take a look at it that I've been able to solve 2 examples without decimal points. So let's move ahead to solve with decimal points, having a value with decimal points. Okay, let's say we are giving another value. So let's say example 3, we are to convert BE.2C in H to P8. So find P. So in the same manner, we just know that we are converting from hexadecimal to mediator, which is binary. And from the mediator, we are going to the final destination, which is octal. So just to spread that out, we have BE2C. Remember to put the dots. Now, B literally means 11. E is 14. And we have this 2. And C is 12. Looking at, we are converting hexadecimal to binary. That is 2 raised to power 4 relationship. So we are using 2 raised to power 3, 2 raised to power 2, 2 raised to power 1, 2 raised to power 0. That's 8, 4, 2, 1. So we are going to use this to find the relationship in here. So we have 8, 4, 2, 1, 8, 4, 2, 1, 8, 4, 2, 1, and 8, 4, 2, 1. So let's ask ourselves, if we want to achieve 11, what will sum up to get 11? Definitely 8 plus 2 plus 1. So since 4 will not be used for that operation, it's going to be turned off as 0. So we have 1, 0, 1, 1. Let's move ahead for 14. 14, how do we achieve 14 here? It's going to be a summation of 8 plus 4 plus 2. So 1 is not used, 1 will be turned off, whereas 8, 4, 1 will be turned on as 1. Moving over to 2, we can actually see 2 here, so we don't need 8, 4, and 1. We'll just on the 2. Remember to put your dots. Okay, so let's consider 12. What will sum up to give us 12? 8 and 4. So it means 8 and 4 will be turned on, while others will be off. So at the end of the day, we are going to have 1, 0, 1, 1, 1, 1, 1, 0, 0, 0, 1, 0. Remember the dots here. 1, 1, 0, 0. Now in this decimal form, how are we going to work that on octal number? Now, first thing in octal is 2 raised to power 3. And that simply means we are going to use 2 raised to power 2, 2 raised to power 1, 2 raised to power 0. 2 raised to power 2 is 4, 2 raised to power 1 is 2, and 2 raised to power 0 is 1. So we have total of 7 because the digits that can be found in octal is from 0 to 7. Okay, so in this sense, we are going to move this way from right to left, then after the decimal points, those decimal values will be from left to right. So please take note of the arrowhead movements. Now, we said we will go with this relationship 2 raised to power 3. This 3, it means 3 digits will be grouped as a set. So now, from these decimal points, I'll consider from here, I'll take 3 digits as a set, year to year, 3 digits as a set, year. We have only 2, so I'll introduce a padding of 0. So I'm introducing this. Now, we move from left to right for the decimal values. That is from year to year, from year to year. And at this point, we can introduce 0 as a padding. Now, after that stage, we are going to put in this value to actually check what we are going to have. 421, 421, 421. So this is just a shortcut for your conversion. 421, 421. Okay. So having gotten this, we are going to check which one is on, and we check that's in this scenario and do the necessary thing. So now we have 1 on here, which is 2, and no other one. So we have the value as 2. In this case, we have 1, 1, 1. So everything we're on. So that's a sum of 4, 2, and 1. That's 7. So 4 plus 2 plus 1 is 7. Now, in this case, we have just this and this turned on. So 4 plus 2 will be 6. Now, let's go to the decimal places. So we have 4, 2, 1. So in this scenario, we have 1. Now, considering here, this was turned off, so we just have 2 and 1. So 2 plus 1 is 3. And this last side is 0. So it's insignificant. So this could tell us that at the end of the day, BE.2CH will be 276.13 in octal number system. However, we were asked to find P. So our P will be 276.13. So we've arrived to the end of this video. So remember, this video talked about the conversion of hexadecimal to octal number system with and without decimal points. Do well to watch my subsequent videos on number system conversions. And if you're just joining us for the first time, do well to subscribe and even like this video so that my video can be recommended to people out there who will be in need of these tips. If you have any question or suggestion, do well to put it in the comment section, and don't forget to hit the like button. So I'll be signing off now. Have a nice time. Bye.